So in the previous video, we seen how to use the software with the one example addition program we done 8-bit addition. So today's we'll discuss about the remaining experiment 2, remaining multiplication, division, and those experiment we'll see this in video how to use in the software, how to check the results also we'll see here. So again, I will repeat this last time. I will repeat in this video how to use the software and make it practice. So here everything it is cleared here. Otherwise, you can go for the close project. So it is already hidden here, no problem. So again, I need to create the new project. Is it clear? So after the new project, where you want to store, so you can check this one. So here you can make this desktop or somewhere. Is it clear? I will create the new folder. So in this new folder it is there. So just I will use some name, something like experiment 2, something like given some names here. Okay. So and the file name is the file name you can give anything. So just I will give some exp2 experiment 2, no problem. So save it file. So after the save, again I have to go for the Atmel. So in that 8089C 51, but in that we are going to use 8089C 82 we are going to use. So select this one, and this one if you want yes, or if you say no also no problem, click on yes. So next one, I need the editor to type the program. So click on file, new, or you can go for this icon, both are same. So here just I will paste the program. So this is the subtraction program. Subtraction program. Okay. So everything it is in the black color. Black color is nothing but it is not yet saved. To save the program, go for the file, save as. Again it will come under the my folder only experiment 2. Exactly. So here you have to give the some name. Any name you have to give. Something like I will give anything name you have to give. Some, for example, here also I will give experiment 2, no problem. But name should be the ASM. Why it is ASM is nothing but this assembly program. So save the file. Then later the color becomes somewhat like in color. That is meaning like that you save this file. So after that, after saving this file, so this one I need to attach to the target. Target is nothing but my controller. So for that, to attach this one, right click on the source group, add files to the source group. Again it will come to my folder only. So here C file, but this program I written, this is the assembly program in this folder. So I have not written the C program, that's why it will be empty. So this one you have to change this to ASM. So here it is comes exp2. This is the name of the file. So select this one. So again you have to observe here none of the file below the source group, that means startup below, none of files are there. Once you select add, this file is going to appear below the startup. Clear? So after completion of this one, save this one. Next I need to go for compilation. So translate. Next build. Next you click one more time rebuild, no problem. So here none of the error 0. So once you get the error 0, then whatever you return the program, everything will be fine. Is it clear? So after the compilation, so I got the result 0. Is it clear? So what about this program already I explained. So here I perform subtraction. Subtraction is nothing but 3 minus 2. 3 I am loading to accumulator, and subtraction a comma hash 2 means this is the immediate value. So that means 3 minus 2 means 1. So 1 is obviously it goes to store itself in the accumulator. So that whatever the result 1 it is in accumulator, next line I am moving to the R0 register. Okay. So how to check this result? Go for debug. So here you can go for the one time run. If you click one time run, it will show the directory results also. Otherwise, if you want, you can go for the step into also. Step into is nothing but it will explain about the each one by line also. Is it clear? So just I will click on the run direct here. So once it will come out is nothing but your program is terminated in for execution mode. So what is the result here? 3 minus 2 means 1. So 1 it is going to store in accumulator. So that means you have to check the content of accumulator itself your result. Where is the accumulator? Accumulator is equal to 1. So that means 3 minus 2 means 1. So that 1 your result will appear in the accumulator itself. So what is the next line? Content of A. I'm moving to the R0. So that means you can check the R0 register content also. That is also 1. Is it clear? So this way you need to check the results in the subtraction program. Is it clear? So in the previous one, you done the smaller by the bigger number. So sorry, bigger number by smaller. That means 3 minus 2. Now I changed it to the 2 minus 3. 2 minus 3 is nothing but smaller by bigger number. Is it clear? So at the time, what do you get the result? You can check it once. So just I will open the calci here. You can verify. Keep on hexa. So 2 minus 3. So that means results will be FF. So that means 2 digits you need to consider FF because of 8-bit data means 1 byte. Remaining obviously it will come FF. So that means it is indicating like this result is a negative number. Negative in the sense this is 2 minus 3 means minus 1. So sign is a negative. So that's why it will show that everything it is in FF. So how to check? That means result will be FF. So just to click on run here. So where is here? Accumulator itself it will show you the FF here. So that means these 2 digits you need to consider. Here also it is FF and R0 also it will come the FF. So in manual you can verify also how it is FF. Already I said 2 minus 3. So convert these 2 into binary. So 4 zeros 0 0 1 0. So 3 is it is a negative. So because of 2 minus of 3. Minus is related to the minus related to 3 is there minus 3. So that means negative number you have to represent in the 2's complement. 2's complement is nothing but how to write 0 3 4 zeros 0 0 1 1. So you have to take the 2's complement. 2's complement means you have to take bit reverse pattern. 4 zeros means 4 ones. Next becomes 1 1. Next 0 0. Again you have to add plus 1. Then only it is the 2's complement. If you add after plus 1, what you will get the result? That one you have to add with the 0 2. Then you will get the result FF. So this way you can verify. So this is the program how to check the results in the subtraction ones. Okay. So we will go for the one more program. So after the subtraction here, we will go for the multiplication. So for multiplication, just I will copy this program. So just I will copy this program. So then I will cancel the debug mode. Then whatever the program is there, just I will make a copy paste because it is not possible to tell again and again the procedure here. But that one you have to make it yourself practice. So how to make the programming multiplication here? So just I pasted here, save the file, go for the errors. Clear? So again errors are 0. So what is this program here? 7F into 3A. So that means here I will clear it. What is that one number? 7F, just 7F into 3A. 3A. So multiplication. Result is 1C66. So that means one number is 7F, one more is 3A. Mul AB means multiply these two. And always the results will be in the accumulator as well as the base, the B register. So in the accumulator, first byte, lower byte C6 will be in the accumulator. B it holds a 1C. So let me to check. Go for the debug mode. So in the debug mode, just click the run here. Okay. So what is the result here? 1C C6. C6 is the lower byte. So C6 obviously it will be in the accumulator only. So 1C. So 1C is the higher byte. So higher byte it will be in the base register only. So that means after main multiplication you will get the 16-bit data as the result. That means 2 bytes will be there. But accumulator base register only the 8-bit register. That's why lower byte it will be in the accumulator. Higher byte 1C it will be in the base register. So this way you need to check the results here. So if you want to change any numbers here, you can change the number directly here also. This way you can make a practice for the multiplication. So next program is the divide. So divide, same thing I will make copy. So just I will paste here. So just I will paste this program. Okay. So just I pasted this program here. Okay. Save the file. So again check the errors. Errors completely zero. Don't worry about the warnings. Go for the debug. So here this is a 7f divided by 3a. So you have to keep in hexa only. Always we are dealing with in hexa. So this is the 7f divided by 3a. So here this is a 2. 2 is the quotient. So you can check it. Always already you know that when you perform the division here you will get one quotient and remainder. Quotient always it will be in the accumulator only. Your remainder it will be in the base only. Okay? That next one I am loading to remainder, quotient A to the R0 sum register. Okay? So you can verify once how it will work. See, check it once. After the one time run here, okay, accumulator is consisting of 2. 2 is nothing but your the quotient. Okay? Quotient is this 2 here, and same 2 also is going to appear in the R0. So here one more thing here, remainder B it will be in the 0B. Okay? So that means accumulator you have to check content of A, and content of B itself your the remainder will be there. So here you got the 2. Okay? 2 already got it. 7f here. This is a 7f divided by 3. Divided by 3a. So here I got 2. 2 is quotient is appeared in the accumulator. So if you want to check the remainder also, how it is came the B. So basically already you know that if you multiply quotient with divisor, multiply the quotient 2 is there, divisor is 3a. That means denominator 3a is there. So 2 into 3a, just to multiply 2 into 3a. Okay? So you got 74. Okay? This 74 you have to subtract with the numerator. Okay? That means 7f minus of 74. So check it one. 7f minus of 74. So that is the B. So that means you are the remainder only. So again I will repeat how to check the remainder. Remainder is the sense you have to multiply divisor with the quotient. Whatever you get the result, that one you have to subtract with the this one 7f. That means numerator. That will be the divisor. That will be the remainder. Okay? So this way you need to check the results of the division program. Okay? Okay? So this way you need to make the practice for the subtractor, multiplication and division. Okay? One more thing I will repeat. Whatever this program, make it practice, because of only not view of lab also. In theoretically sometimes they will ask you the programs. Okay? When you are going to make the practice, then you will get the logic how to write the programs in respect to the theory exam. Okay? And remaining other programs I will tell you in the next videos.